Okay, 2003 um, AP Free Response question 5. A student is instructed to determine the concentration of a solution of CoCl2 based on the absorption of light. And this is spectrometric or colorimetric method. Basically, this is Beer's law, and the thing is, when you have a colored solution, the more concentrated it is, the darker it is. So if you've ever made Kool-Aid, you put a pinch of Kool-Aid powder into a half gallon of water, it's going to be pale, pale pink. But as you add more and more and more, it gets darker and darker and darker. So this method actually only works with solutions that are colored. A student is instructed to determine the concentration of a cobalt 2 chloride based on the absorption of light. The student is provided with a 0.1 molar solution of CoCl2 with which to prepare standard solutions with 0.02, 0.4, 0.6, blah, blah, blah. Describe a procedure for diluting 1 molar solution to a concentration of 0.02 molar using distilled water, a 100 milliliter volumetric flask, and a pipette or burette. Use specific amounts as possible. Okay, so now anytime you are diluting one solution, a liquid solution, to make another solution. Now, there's 4 Spec 20 labs required out of 16. 1/4 of the labs on the AP exam are from using the Spec 20. 1 in 4 of the required labs. It's hugely important. You guys have this equation that only applies to diluting a solution to a different concentration with the stock solution. I actually prefer to write the equation like this: MCVC, where C stands for concentrated, and then MDVD, which stands for dilute. And the thing is, you can make a concentrated solution more dilute by adding water, but we never make a more diluted solution that's dilute more concentrated by removing water, because that's hard to do. You'd have to heat it and let the water boil off. So and so the question is, if you look up here, the initial concentration is 0.1 and the dilute concentration is 0.02, and that's a volume, because the volumetric flask is, there's 100 mil, 200 mil, 250, 500, and 1 mil. No, sorry, 1,000 mil or 1 liter. And so, you can't make 455. You have to make 500 and then just not use part of it. Okay, so the question is just diluting. So I want to know the volume of the concentrated solution that I would need to measure out to put into the 100 milliliter flask. So MdVd over MC. And so if you look here, they want the concentration of the dilute solution to be 0.020 molar, and they want the volume of the new solution to be 100 mils, and this is one of the few times in chemistry that the volume has to be in liters. And the original concentration is 0.1 molar. And in molar, we cancel with molar. And one of the things that I need to point out, this is the old test, not the new test. In the old test, you didn't get a calculator for 4, 5, and 6. So on the free response 1, 2, and 3, you got a calculator, and for 4, 5, and 6, you didn't. So if you'll notice, think of 2 cents and 10 cents. This is 1/5 of 100 mils, and then 1/5 of 100 mils is 20. And then we're going to answer this in sentences. But without a calculator, this wasn't a bad problem. This has 2 sig figs, this has 2 sig figs, this has 3. I would probably do something like this. And then describe a preparation. You would, using a pipette, because it said in the words, a pipette or a burette, so pick one. Measure out exactly 20 mils of 0.010 molar COCl2 solution. Transfer to the 100 milliliter volumetric flask. And add water until, I gotta extend this page, sorry, until the volume is exactly 100 mils. Because here's the deal. You have this volumetric flask. Keep in mind, I'm the worst drawer on the planet. Okay, these are the ones that have the round bottom. That's so bad. And it holds up, and remember there's the line, and you have to have the meniscus. So what you do is you transfer in 20 mils. Well, it can hold 100, and so then you put in 80 mils of water, and for a total volume of 100, well, 20 divided by 100 is 1/5. So what happens is you make it, remember molarity is moles per liter, and when you make this 5 times more, the volume increases by a factor of 5, you're dividing by a 5, it makes it 5 times less concentrated. So hopefully that answer is okay. And then 2, the student takes a 1 molar solution percent, okay, absorbance. Okay, so interesting, the reason why they did this on the AP exam is they want you to understand that something happens when you pass light through a colored solution. By the way, copper 2 chloride is pink. Some of the light gets through, it's not usually to the detector, and some of the light doesn't. And the light that gets through is called transmitted light because it gets transmitted to the detector. And the light that doesn't is called the absorbed light. Just like a sponge sucks in water, the absorbed light gets sucked into the solution. And Beer's law is the absorbance of a solution is equal to ABC, where A is the molar absorptivity constant. Each molecule has its own. B is the path length. So, if you've ever played with a light, like a flashlight, and you shine flashlight through a solution, the longer this is, the less light gets through. So if you have a little tiny thing, most of the light gets through. And so A is the path length of the cuvette, and C is the concentration. And one of the things from Beard's law is it's supposed to be done at maximum absorbance. And basically what that does is it just stretches it out. And so it looks to me like this is approximately 510 nanometers would be the best. I mean, if you use this or this, you'd still get a good stretched out graph. So, and notice where you have maximum absorbance, the wavelength at which the solution is sucking in the most light is the wavelength that the least amount, if you know your calculus theory, this is a min, this is a max. So wherever this is maximum, this is minimum. Wherever this is maximum, this is minimum, because they war against each other. C, okay, so then they do this thing, and this is linear, and if the absorbance is 0.275, so the absorbance is 0.275, so here's 0.2, here's 0.3, here's 0.25, 0.275 would be roughly here. Okay, that's really bad. And it looks to me like they set it up so this would be 0.050 molar. Not a lot of work to show on that one either. D, Beer's law is absorbance equals ABC. A is molar absorptivity constant. Each molecule has its own. It's a constant. B, I like B, I do B and C the best. It's path length. and path length is generally measured in centimeters. And then C is the concentration. We know the more concentrated it is, the darker the color is. Concentration is always measured in molarity or moles per liter. And then the absorptivity constant, because this is unitless, so it would be in something like some constant number over centimeters times molarity, because when you multiply a centimeter times molarity and then times whatever, you can look on your formula sheet. That was actually a pretty easy question. E, a student handles the sample container and holds the unknown solution and leaves a fingerprint in the path of the light. How would this explain the calculated concentration? So here's the deal. You don't wipe this off with, Kleenex or whatever, and you get your big oily fingerprint here. Well, in comes the light and it doesn't get through. And so what happens is, if you have a fingerprint, it seems like the absorbance goes up because less would get through. If the absorbance goes up, then the concentration would go up, because if this number's bigger and this is a constant and this is a constant, if this is bigger, this needs to be bigger. And so how will this affect? So you would say something like the calculated concentration would be greater than it should be because less light gets through to the detector. If you look at the scoring guidelines, it'll say something like more light is scattered. More light is scattered, which I thought was kind of interesting, because most of you guys are also in physics. So what happens is, when the light comes in and hits this oily fingerprint, it doesn't get through. It like bounces off, and it doesn't get through to whatever the detector is here. And so you have transmitted light and scattered light, however you want to say it. And then F, why is the method for determining the concentration of COCl2 appropriate, whereas the same method for measuring the concentration of NaCl would not be appropriate? Sodium chloride solution, if you've ever made it, is colorless. And so remember, this only works, it's called colorimetric analysis or photometric analysis. It works because on a colored solution, the hue or the color gets darker as the concentration goes up. It won't get darker as it gets more concentrated. The other thing to say is, if you like this better, spectrophotometry. Hopefully I'll be talking about this in class, but photons is what we call a particle of light. Spectrophotometry only works on colored solutions. However you want to say that. That's actually a pretty good problem in terms of reviewing Beer's law and maximum absorbance and all that stuff.